For this lesson, we're going to continue along the topic that I started previously, which was looking at measures of spread. In this case, I'm going to take a look at a very specific and very important measure of spread, which is called the standard deviation. And then I'm also going to use that standard deviation to talk about and to calculate something known as a z-score. There's a lot of terminology here. The equations, as you can see from a couple of the equations that are very similar to each other, they're very complicated, especially for people who are new to this. So I'm starting with some definitions and these expressions, but I'm then going to go through each of them, or not each of them. I'm going to go through a sample calculation in order to hopefully show you that it's not really that intimidating. So first of all, um, standard deviation has the word deviation in it. So first of all, what are we talking about there? The distance from the mean. So we're going to calculate the arithmetic mean, and the deviation is how far is some other point from that mean. Now, the way that we start to talk about that is we need to take a look at the overall data, and we have to get an idea of how that data itself is spread. Now, we've already looked at one method in the past, which was to look at the quartiles and to draw a box and whisker plot. That was one way that we could measure the spread of the data. This is just another way, and as is the case in mathematics, someone would have proposed this. This isn't something that would be derived. This is something that someone would have assembled. They would have done some thinking about what made sense, what worked, and so they came up with this through a process of educated trial and error. Because there are multiple ways to measure spread, and it was determined that this was a way that could be used to measure spread. And as it turns out, this is one of the more common ways, maybe the most common way to measure spread in data. So we can go from the idea of deviation to variance, and then the standard deviation. So the variance is just a very specific type of calculation, and the standard deviation takes the variance calculation and it just puts it into a slightly more useful form by taking the square root of the variance. Okay, so what I have for you here, these are the different expressions. One of them is the standard deviation for the sample. That's why I put a subscript s here. You don't have to carry that s all the time, but you do need to know whether you're working with a sample or whether you're working with the population. Again, something I talked about in a previous lesson. It's easier to actually start over here with the population. A population means that you are dealing with every single piece of data that is possible for that set. So somehow you have the data for every member of the set, for every item in the population. A sample means that you are not working with the entire population, and it just changes your calculation a little bit. You can see here when I'm dealing with the standard deviation for population, I end up dividing by the number of items in the population. When I'm dealing with the standard deviation for a sample, I actually subtract 1 from this denominator, which is going to make this overall result just slightly larger. And what that's saying is when I'm working with the sample, I'm not as sure about my results, and so my standard deviation gets a little bit inflated just because I used a subset of the overall population. If that's a bit much to take in right now, don't worry about it. In practice, we are going to be working with the standard deviation for the sample almost all the time, perhaps all of the time. So we are really just going to be applying this formula. So let's talk about the z-score as it relates to this. So you can see I've put together kind of a modified number line along the bottom here. And in the middle of that line, I have put the mean. Okay, so that's the mean of the data. That's one of the ways that we can measure central tendency. So I've calculated the mean or the average of the data, and it ended up right there. What the standard deviation tells you is basically it's a way of measuring, okay, how much data is between the mean and one standard deviation. So each of those, that's +1 and -1 standard deviation. So how much data is there between the mean and one standard deviation in the positive direction and one standard deviation in the negative direction? And then we can also ask about 2 standard deviations, 3 standard deviations, etc. Now let's focus on just that one standard deviation. Well, a z-score is just a way of assigning a number to that concept of one standard deviation. So a z-score of +1 simply means that you are one standard deviation to the right or in the positive direction from the mean. A z-score of -1 means you are one standard deviation to the left of the mean. And that's it. So you can see the z-score calculation. Well, what does it make use of? It makes use of the mean. It makes use of the standard deviation itself. And then it makes use of the particular data point that you are interested in. Okay, so if you've calculated the mean and you've calculated the standard deviation, you can look at a z-score for any particular data item. And again, I think it'll be easier if we look at this in practice. So I'm going to move on from there. Now, if this was a class, I wouldn't have you writing this down. It's got a blue background. Steps for calculating standard deviation. There are a lot of them. In this lesson, we're going to calculate a standard deviation by hand. We're going to calculate some z-scores by hand. But beyond that, beyond doing a couple of questions for practice as part of your assigned work at the end, you would use technology to do this. Particularly, I'm going to do a very small data set. The assigned work I'm giving you is a slightly larger data set, but still doable by hand. But I'm not giving you anything ridiculous. I'm going to do a later a tutorial or a video lesson to talk about how to do all of this using technology as well. And that will be our expectation going forward. You have to be able to show me that you can do this calculation, but I'm not trying to turn it into any more of a chore than it already is. So let's take a look at this example that I've created. As you can see, this example only has 5 data points, and I ask you to calculate the standard deviation and the z-scores for this sample data. And so in order to be able to calculate the standard deviation, here I had a long list of different things to do, and I didn't even talk through those. But if you want to, you could come back and revisit this, and you'll realize that we've done a bunch of these things. As a matter of fact, we've done all of them by the time we're done. So here are my data points. So the first data point is 33. The second and the third are duplicates of each other. They're 64, 55, and 66. And I actually generated these data points using a spreadsheet, just using some random numbers, and I was careful about how they were distributed. So the first thing we want to figure out is, well, we've got a few things here to figure out. I've circled them, the ones I want to start by doing calculations of. This is a particularly easy one to fill in. There are 5 data points, 1, 2, 3, 4, 5. In order to figure out the arithmetic mean, I actually need to know the sum of these values. So I have a calculator handy. 33 plus 64 plus 64 plus 55 plus 66. I add all of those up. This is my summation notation. The summation of all the x values is 282. And so the mean, I divide 282 by 5, and I end up with 56.4. And that ends up being my arithmetic mean. And what I've done to try to streamline this process a bit is I've kind of put these prompts in here for me, and now I've filled in the ones for this page. I go to the next page, and I've got that stuff filled in. 282 and 5 and 56.4. So now that I know those 3 important pieces of data, what I'm going to do is I'm going to take each individual piece of data and I'm going to subtract the mean. So for example, I'm going to take 33 minus 56.4, and 33 minus 56.4 gives me, 33 minus 56.4 gives me negative 23.4. And I could do that here. 64 minus 56.4 gives me, sorry, I'm going to double check that, minus 56.4. That gives me 7.6. And to make sure, just a quick check, to make sure you're doing this right, if this number is less than the mean, your result should be negative. If this data point is greater than your mean, the number should be positive, which it is. I also want to calculate the squares of these things. And so I'm going to take negative 23.4 and square it, which of course turns it into a positive, and that ends up being 547.56. 547.56. And then I take 7.6 and I square that. And in that case, I get 57.76. 57.76. And I do the rest of my table, filling those in. And once I have the sum of these differences, but I take that sum of those differences and I square each one of them, then I add them all up, then I can fill in this value. And I've got that prepared on the next page. That works out to be 757.2. Now this would be a good time to draw your attention back to the formula for the standard deviation that we want to make use of. You can see in this formula, in the numerator of that fraction, we have the sum of xi minus x bar all squared. That's what we just figured out here. So that's why we needed to go through this. Now that I've done that, just going to get rid of that blue. Now that I've done that, I can calculate this part. This is the Greek letter sigma. I should have mentioned that at the beginning in case we haven't come across that yet. So this is the Greek letter sigma, which is basically a circle with a horizontal bar across the top. And this represents, because this is sigma squared, this represents that property called the variance. Where's my eraser? And so the first thing we're going to do now is use this number to calculate the variance. Now the variance is sigma squared. So basically I'm going to do this calculation in the corner, but without taking the square root yet. We'll be taking the square root in just a moment. So I take that result, 757.2, and I divide that by n minus 1. Now n was 5, so n minus 1 means I'm going to divide that by 4. And I end up with 189.3. And then I can take the square root of that in order to figure out the standard deviation, which works out to be 13, and I'm just going to round it to 13.8. So now I have found the variance and I have found the standard deviation, which quite often you'll see abbreviated that way if you want to express it in words. So now I'm pretty much there. I've calculated my standard deviation. I've calculated my mean. So what this is saying is that the data, now it's not a very big data set, those 5 data items are centered around 56.4, and then they have a variance of 13.8. So if you started at 56.4 and you took a step upward of 13.8, you would expect to find a grouping of data in that first interval, and then you could continue to step upward and upward and upward. This z-score is basically just going to give you a numeric representation for any data point. It's going to tell you how far away is it from the mean. So I have now filled in everything else here. And let's go ahead and calculate. I'm just going to do one of them. So what is the z-score for this piece of data, 33? So what I'm going to do is I'm going to take 33, that's the data point, minus the mean, which is 56.4, and then I will divide that by the standard deviation, which is 13.76. And so when I do that calculation, 33 minus 56.4 is negative 23.4, which actually, you know what? I could have saved myself some trouble. Negative 23.4 is right there. So I could have actually gone directly to that number divided by 13.76, and I end up with negative 1.7. So this value, 33, is 1.7 standard deviations to the left of the mean. And I could repeat that for each of these, and I did repeat that, but I'll admit I repeated it using a spreadsheet, and I got all of these values. On their own, there is no calculation that I've done here that is oh so terrible. The only problem is it does get very tedious very quickly. Okay, so like I say, I'm going to ask you to do a couple of these by hand, but then I'm going to introduce the technological way to do these, and that will be my expectation from that point forward. And that's it for this lesson. So it's not covering a whole lot. It's really just covering a process. And so you can see from the assigned work, I've got a couple here where I only want you to calculate the standard deviation, no matter what the text in the question says. And for those ones, I'm asking you to do that by hand, just so you can gain an appreciation for it. And then I'll show you how to never have to do it by hand again.